Hello, welcome back to our last data mining lecture on this lovely Monday night. I hope you all enjoyed your weekend. This Wednesday, we are going to have our comprehensive exam. And today, what we are going to do is to first finish our slides. We still have 2 more slides. Then we are going to review, if you guys want, we can review the content of the entire semester. And we are going to talk about rules for your comprehensive exam, okay? All right. I think we were here. So still remember the problem we are discussing here? You have queries, you want to pair queries with ads, and there are many complications. Every advertisers could bid on different keywords, and each one of them has a monthly budget, and their bids could be different. The click-through rate could be different as well, right? So many complications. And we talk about these competitive ratios that can help you measure the performance of a matching algorithm in terms of the worst case. And we say that we show that for the greedy algorithm, your competitive ratio is 1/2. For your balance algorithm that consider budget, you have a very interesting competitive ratio, 1-1/E. All right. So we also talk about generalized balance algorithm that consider bits and all that. All right, so what are the things that we have not discussed in our model? So the general problem, is to match bids with search queries. In our simplified models, your advertisers bids on a set of words, and advertiser's bid can be shown for search queries with exactly the same set of words, right? So we always consider either you bid the words or you don't bid the word. But in reality, all these search engines offers broad matches. So woman's head versus lady's head, right? So this create one more complication, because now what if the match is 0.6 versus a match is 0.8? Which one do you want to show? That might affect the click-through rate as well. So charge your advertisers based on complicated formulas that take into account how closely related the search query is to the bids is the way to go now. But then think about your balance algorithm. In the generalized version, you already are considering the amount of the bid, the budget, and the amount of the bid also include the click-through rate, right? So now you also have to consider related search, how related the search query is to the bid. So these are usually proprietary algorithms. Also, charging advertisers for clicks in our simplified model. When the user clicks on an ad, the advertiser is charged with the amount they bid. This is called the first price auction, right? In an auction, you bid, and if you win the auction, you pay for what you have bid for. In reality, your search engine uses a more complicated system called second price auction. This has been in many different real-world auctions for a long time. So what is a second price auction? This means each advertiser pays approximately the bid of the advertiser who placed immediately behind them in the auction. For example, your first place advertiser, if you are the search engine, you want to charge the advertiser, you're not going to charge the advertiser for the amount they bid. You will charge them for the amount of the bid of the second place advertiser plus maybe 1 cent. So in ideally, this approach, second price auction, is less susceptible to being gamed by advertisers with first price auctions. So this is very interesting. If you're interested in this, you should read about this. And this also leads to higher revenue for search engines, because now if you think about, if all your advertisers team up and they agree to bid very low amount for certain keywords, then you are not really getting the profit, right? So this is just one approach to prevent your advertisers to work together and also to maximize your profit. All right, that's everything I want to tell you about data mining. I know we only covered a small subset of the chapters in the textbook, so I highly recommend you to read every chapter of the textbook and find online competitions so that you will be able to work on other topics. All right, before we go on, I want to talk about any questions. Also, any questions for the exam? Okay, so here are the rules for the exam. I have posted this on Piazza, but I just want to go over this because this is very, very, very important. We do have a number of plagiarism cases and cheating cases for your quiz this semester. And I just want to eliminate all cheating possibility as possible for the comprehensive exam. All right, so we're not going to use the lockdown browser. Awesome, no lockdown browser. Okay, so we're going to use Zoom for your comprehensive exam, and you do not need a lockdown browser. The process is very simple. During the exam time, which is Wednesday, 6 p.m. Pacific time this week, you host a Zoom meeting. You can actually host a Zoom meeting before the exam and start to share your screen. Then once you start to share your screen at 6 p.m., you log into Blackboard, you navigate to the exam, and you start the exam. You will see the exam on 6 p.m. well, during the exam time. I believe there's only one person in this class requires spatial time arrangement because this person is not in the US. So everyone else should be able to attend the 6 p.m. exam. All right, so you turn on your Zoom, you open your browser, you go to Blackboard, make sure you turn on your camera. I need to see you on camera. But the whole point of seeing you on camera is to make sure that you are not using any other devices to communicate with other people. You have to share your screen. On your screen, you should have your Blackboard. Let me just do an example. Okay, let's see. All right. So this is what I want to see during the exam, in the video that you are going to submit. I already have the comprehensive exam on Blackboard, but it's not available for you. You will be able to see it on Wednesday. So let's just try this comprehensive exam. Once you do this, you share your screen. You can log into Blackboard, share your screen, click on the comprehensive exam, read. Important, you need to read this because it will tell you the time limit and when you need to submit. Okay. Then you begin. You start to work on the top, the questions. Go to the next question. Then you submit. Okay. When you submit, make sure you submit your exam before 7 p.m. because you have 1 hour. Then you just click on OK. And you should be able to see your score immediately. So that's what I want to see. And other than Blackboard in your browser, you can use a calculator on screen, but you need to show the calculator on screen. So in general, I want to see your mouse cursor in the share screen all the time. Okay. All right. So once you are done with the once you are done with the exam, you can wait until the next day when Zoom process your video and share your video by link form somewhere here. Let's go through all these items. So if you don't know how to use Zoom or host a meeting, here's a link. How to record Zoom meetings. Here's also a link, but I'm pretty sure the ITS link has information about recording Zoom meetings. Make sure you do not record to your local disk. You should record it to the cloud. Your camera should be on, record you for the entire duration for the exam. You can finish early. You don't have to stay for the entire hour. Your Zoom session should only have one person, and that would be you. Your shared screen should show your browser only, except a calculator application. Well, depends on your operating system, but you can use a calculator. You also can use an external calculator. Let's say you want to use a calculator on your phone, but then you have to do this. You have to show me that you're using the calculator. Okay, there's a question. So question, for the exam, along with the camera and screen share, do we also keep ourselves unmuted? That's a very good question. Yes, you should. Thank you. All right. Next question. Is the number of questions the same as mentioned before? Oh, no, I reduced the number of questions to 32. Just to make it easier for you guys. All right, 32 questions in 60 minutes. Are we allowed to make draft? What do you mean by draft?
Scratch paper.
Oh, you can use scratch paper, yes. Can we open any empty notepad to record? You can use pen and papers. But please, if you want to use it, just show me. You cannot do it on iPad. You cannot use other electronic devices. So the calculations are relatively simple with a simple online calculator. Yeah. All the things that we did in this class are simple math. Can we change our responses to the questions after we have marked them and go to? Yes, you can. All right. So where were we? Here. All right. So I think everyone understand here. Very, very important. This is a closed book exam. Do not use other materials. The questions are randomized. And please follow the USC academic conduct. Well, I'm listing this here because sometimes if we catch someone, we will get a response say, I didn't know this violate the rule. So make sure you read the rule. Since you are going to administrate your own exam on Zoom, please make sure you turn it in on time, because nobody is going to tell you that, hey, there's only 5 minutes left. Everyone will start the exam at the same time, except one student that's in Europe. The duration of the exam is 60 minutes, not 30 minutes. I think I updated this on Piazza already. If there is any change in the duration, you will see it on the first page when you start the exam on Blackboard. So now I'm telling you it's 1 hour, so it will not be less than 1 hour. Okay, so question, is a proper calculator allowed? Yes, a calculator is allowed if you want to show it on camera. Just don't use any other electronic devices, tablets, phones. One more question, does the exam auto submit at 7 p.m.? No, it's not. How to upload the recording? Very good question. You should follow this link to read about record Zoom meetings to the cloud. You don't need to upload it. Okay, so this is very, very important. You don't need to upload it. You record it to the cloud and you share that link with me. So today for the quiz, we can try this. So your quiz will be at 7:20, but let's start at 7:15 so that you can start to try this exactly the same process, but for your quiz. There's one more question. Is there a partial point for every question? No, there's no partial point. All right. Are there questions where you choose one answer and also where you choose several? Yeah, you choose one or more answers. Okay, so here. If you already oh, this is important. If you have a DSP letter showing that you need accommodation for the exam, if you already have one and you send a letter to me, you can have the extended time for the exam according to your letter. So if your letter says you can have 1.5 extended time, then you have 90 minutes. But nobody is going to tell you that you have to submit at 7:30, 7 p.m. So you have to do it by yourself. If you turn in your exam late, every minute you will receive 1 point penalty. There is no exception. Okay, so Perry has a question. So if one person got half correct on every question and spent an hour on the exam, this person got 0. Yeah, 0, no partial credit. If there are multiple correct answers, there should be points for correct marking, correct option, negative point for. That's really complicated. No, you just have to select all the correct answers. Will there be one answer only questions? I cannot tell you that. Okay. All right, once you submit your exam on Blackboard, you can close Zoom, and Zoom will let you know when the recording is ready on the cloud. Once it's finished, submit the link to your exam, to your Zoom recording here. And we're going to review your recording and then finalize your grade, but you should be able to see your grade once you submit it. You need to submit your recording before the midnight, April 29th, or you will receive a 20% penalty. All right. So I think this is the easiest way for you to do the exam. Since we don't have lockdown browser, we don't have all this AI monitoring you. We just ask you to record yourself, submit the video so that we can look at the video. Any more questions?
Yeah, Professor, I meant that, so there won't be any questions that actually say, please choose one answer. They're all going to be eligible for one or more?
I cannot tell you that. That's not.
Okay, got it. Okay.
All right. Any more
Hey,
questions?
Professor.
Yes.
Is it possible to set up some kind of, force submit, like when it's 7 p.m., the platform is gonna submit the exam automatically, something like that? Because I was concerned that if we wait until the last minute and then there's some network, delay, and even just past 1 second or something, the system is going to show like 7:01, So
Yeah.
is there a way to do that?
Yeah, there is a way to do that on Blackboard, but there's a couple reasons that I don't want to do it. First, we do have students that will require more time. So if I force submit, I will force submit everybody. Second, some student might want to use the extra time to work on questions, right? So, because 1 minute late is one point penalty in each question, because since we have 32 questions, each two question is about 3.21 points. So if you need that 1 minute that you can get the question right, you probably want to do it. There is no buffer time, and the total score is 100 points.
Okay, thank you.
Sure. Okay, any more questions about the exam? So I don't expect there will be questions during the exam. If you do have questions, you can email me. I will monitor my email. So when you email me, give me your Zoom link, then I can join your Zoom meeting room to answer your question. All right. So for your exam, it will not be easy, but it will not be difficult. It's rewarding, means if you do study, you will get your point. Rarely that when people study, they don't get their point in our exam. All right, so let's review the materials. Should we review the materials? Which chapter do you guys want for a review? Okay, AGM. Everyone, all okay. All right, let's just do all of them, but I'm going to do it very quickly. Okay, MapReduce. So when we are doing this review, the way I'm going to do this is I'm not going to explain again the concept, but I'm going to tell you what are the things that you should know and what's the takeaway from each topic. Okay, so MapReduce is fairly simple concept, right? You want to be able to parallel process large data set, and you need a programming model that will be able to help you to do that and remove all the overhead, like syncing thread. But what would be an important thing about MapReduce? Let me see. Okay, here. This is the things that you should know, right? What are the challenges MapReduce has addressed? Because these are universal challenges. It's not limited to a Spark implementation. Then you need to know about distributed file system, something like this. You should be able to draw something like this and explain why we need replications. Once we have that, talk about chunk servers. And this is important. Not that this graph is important. It's important that you understand different computing nodes in a MapReduce environment, right? Like you have map nodes, you have reduce nodes, you have name nodes, and you have secondary name nodes. Why do you need them, and what do they do? So, and all these are MapReduce tasks, right? We work on many MapReduce tasks. You need to know how to write MapReduce code. And I think something is very important somewhere here is the combiner. Where is the combiner? Oh, here. So why do we have a combiner? Well, you want to reduce the overall network or data transmission cost, right? So how does combiner work? Where do you run a combiner? What if a combiner or a map task or a reduce task fail? What do the MapReduce framework do? That would be important. And you also need to know what would be the case that you can use a combiner, what would be the case you cannot use a combiner. You have to be able to explain why combiner would be able to help you save network transmission cost, data transmission cost. Okay, so I think that's somewhere here, computing average, and then we are done. Oh, one thing that's important is I think in your homework assignment, you work on very simple MapReduce tasks, right? So to understand which part of the MapReduce tasks that you have to write as a programmer, what are the parts that are supported by the framework is important. All right, second set of slides. Okay, second set of the slides mainly is talking about the data flow in a MapReduce environment. So where do map tasks store their data? Where do reduce tasks store their data, and how they coordinate all this data transmission? And what are the real data transmission that's required in the MapReduce environment? That's important. For example, we talk about once a map task is finished, the data, the intermediate result is stored on the local disk of a map machine, right? And then how do you transfer that intermediate file to a reducer? Well, your name node will tell the reducer that the task is done and give the reducer a pointer to the file so the reducer can fetch the file from the map task. So this is important. This is the data flow part. You need to understand when something failed, what would the MapReduce framework do? How many map and reduce jobs? This is important as well. I think I believe in your textbook, there's a couple paragraphs that discussing this. So please read them. Combiner, refine partition function, these are important as well. And what else? Matrix multiplication is important. I think this is the most commonly used interview question for MapReduce, and it's very useful too. All right. So why do we have one phase? Why do we have two phase matrix multiplication? And okay. So general characteristics of good problems for MapReduce. This is also very important, right? You want to be able to know what are the things that you can deal with MapReduce. What are the things that you do not want to use MapReduce to deal with? Okay. All right. Then we're done with MapReduce. Frequent item sets. So in frequent item set and association rules, remember when we start talk about these algorithms, the first thing I told you is, where is it? Association rules are very important. Right, so association rules are like this if-then rules. When you see something, you might see something else in a basket. You need to be able to calculate the confidence score and the interest score of an association rule. And once we talk about association rules, we talk about, hey, if you want to generate association rules, you need to be able to identify frequent item sets, right? And we talk about a number of limitations of naive approach of just counting them because you will not have the memory space to store them. And we talk about the basic two approaches for storing your counters, this triangular matrix and the triples. You need to know their differences and how you use them. Now, once you get past this data structure part for storing your counters, we start to look at algorithms. The first family, algorithm family, is a priori. So in the priori algorithms, we talk about this, right? You count single items first, then you use that to help you create filters for your second phase so that you can count a larger file without using extra memory space. And that's a priori, but with a priori, detailed information in this memory map is also important, right? So what is the old item numbers? Why do we need them? What is these frequent items? Why do we need them? All right, that's for, this is for counting pairs. And also you need to know, now you know how to count pairs, how do we go further to count triples and all the frequent item set of all sizes. All right, that's a priori. And we talk about a priori-based algorithms, right? PCY, multi-stage, multi-hash. For PCY, the idea is that we should be able to use this empty space in your pass one to help you create a stronger filter so that you don't have to count that many pairs in your second pass, right here. So you still are reading two passes. So for the PCY algorithm, you should be able to explain how the number of buckets in the hash table would affect your performance. You need to be able to explain what exactly are the frequent items here, bitmaps here, and what is the criteria that you have to count candidate pairs in your pass two. All right, so that's PCY. After PCY, we talk about multi-stage. Again, very similar to PCY, but you use more than two passes to count pairs. And you need to be able to discuss what's the relationship between these two hash tables. How do you use them? How do you construct hash functions? Well, easy, right? They are independent hash functions. And you need to talk about what are these bitmaps and what are the criteria for counting pairs in the last pass. And also you need to be able to talk about the benefit and the pros and cons for the multi-stage algorithm compared to simple PCY. Once you have the multi-stage, we talk about multi-hash. So the idea is to have multiple hash functions in your first pass so that you have multiple bitmaps here. So you need to be able to talk about what will be the pros and cons for a multi-hash compared to multi-stage and PCY. You also need to talk about how this algorithm works, right? Just like multi-stage. Okay, but in general, all these algorithms, you need to be able to hand draw all these passes of their memory space. I don't want you to forget that you need two bitmaps here, or you need the frequent items here. All right, so third set of slides. Finding frequent item set. The last set of slides, we talk about limited pass algorithms. And the idea of limited path algorithms is sometimes we do not need to find the exact collection of frequent item set. We only need some approximate answers. So how do we do that? The first approach is random sampling. Extremely easy. You just take a random sample, but you need to understand how you would sample the data set. And you need to understand you need to be able to explain how the algorithm works, right? So important thing here is to generate sets of all sizes, not just pairs in one row. How to pick samples. Oh, and you need to be able to explain how to set your support threshold for random sampling. If you make it smaller, if you make it larger, what will be the difference? How does it affect your false positive and false negative rate? All right, that's random sampling. For your SUN algorithm, again, you need to be able to explain how SUN algorithm works and how SUN algorithm is related to MapReduce. I think everyone, if you submit your assignment, you should be able to explain this very well, right? Okay, so the SUN algorithm. All right, there's two phases of MapReduce. You should be able to write this. Then we talk about Toivonen algorithm that will give no false positives and no false negatives. And we talk about negative borders. You should be able to explain what exactly is the negative border and how does negative border help us to make sure that there's no false positives or false negatives. All right. And the FP graph algorithm, you should be able to explain the FP graph algorithm, compare it with a priori, right? You need to be able to explain the pros and cons of the FP graph algorithm. The entire idea is very simple. In 2 steps, you build a compact data structure of the FP tree. Then you just look at the FP tree to identify the frequent item sets of all sizes, right? So how do you construct the FP tree? And how do you generate this? Where is it? Oh, here. Why is fixed order important? Because it can overlap, the paths can overlap. So you can build a smaller tree. This is important. And you need to be able to do this, right? Create FP tree. Once you create the FP tree, you have to be able to mine the FP tree like this. Generate all this conditional pattern base, and based on that, generate a conditional frequent pattern tree, then generate frequent patterns. Okay. All right. Any questions so far? The next topic is finding similar items. So we talk about Jacquard similarity. We talk about finding similar buyers, there's different things. You need to be able to explain why frequent item set algorithms cannot work on this problem of finding similar items. And what else? Oh, and then we start to talk about a real application that's finding similar web pages. And because we talk about many ways to find similar documents, you need to be in this class. You can have TF-IDF, right? So you need to be able to compare them and explain in which case you should use which algorithm. In here, we are taking shingles. And the idea of shingles is you are trying to find nearly identical documents because you're creating all these shingles. You are not really finding documents with similar topics. That's for your TF-IDF. So you need to be able to explain what's shingle. So shingle is somewhere here. Right, you need to explain this shingles and you need to explain the maximum number of K shingles because this has an implication of here, right? Because when you have a document, you have k shingles, you need to be able to estimate how many possible shingles can come from one document. What will be the probability that two documents share the same shingle randomly, right? So how do you pick the k? This is important. Number of shingles. Oh, then we talk about min hash signatures. Because once you have shingles, each document becomes a data point represented by a really long feature vector of shingles. And because you have many documents and you have a very long feature vector, we want to be able to first create min hash signatures so that we can reduce the dimension of your shingle vector. We talk about this min hash algorithm. You need to be able to explain the characteristic metrics and how to generate min hash signatures. And you need to be able to prove this, right? Because this is the basic underlying theory that support our min hash algorithm. And you need to be able to do this, right? Instead of shuffling the entire table, we are using hash functions to shuffle all the row IDs so that we can scan the entire table once, right here, and generate all the min hash signatures with one scan of the table. You have to know how to do this. Okay, then you need to know how to estimate similarity using signatures in locality sensitive hashing. So for locality sensitive hashing, you need to understand the bucket idea, right? You need to be able to explain candidates and bucket and why are we doing LSH. And the LSH algorithm is fairly simple. You have to be able to know how to do it, right? Split into band, and if two bands are identical, they are candidate. The most important part of the LSH algorithm introduced in our class is this. You will need to be able to derive this, right, from this SR and B, and you need to know how, if you change R and B, how this line, this curve will change its shape, and how does it affect your false positive and false negative rate. And you should be able to explain this, right? So which area is false negative, which area is false positive, what is a predicted threshold, and all that. All right, so that's it. Yeah, here are all the different ways that you can change the graph, change this function, and change your false positive and false negative rate. And you also need to know how to do this, right? How to find similar documents by combining all the techniques that we covered in this set of slides. Create shingles, create min hash, create LSH buckets. So in general, before we take the break, in general, the things that I want you to know is you need to understand how to implement the algorithms, right? You need to be able to explain how the algorithm works. You need to be able to explain why the algorithm works. And you need to be able to explain to you need to be able to use the algorithm in an application like here, finding similar documents, right? So sometimes people would focus on, all right, I know how k-shingles works, I know min hash signatures works, I know LSH works, but I don't know how to put them all together to do to find similar documents, right? I think this is very, very important. This is also very important in the content-based recommendation system for your TF-IDF stuff. All right, let's take a 10 minutes break, come back at 7 p.m. So during these 10 minutes, I want you to look at, just make sure you know how to record your Zoom meetings online. record it to the cloud. And if you have any questions, put it in the chat. I can answer them when I come back.